Hello. So today I'm going to solve a problem on Leetcode, problem number 114, flatten binary tree to linked list. So I just read this problem. Let me write down the title of the problem. Binary tree to linked list. This is an interesting problem. The difficulty of this problem is medium. So it's not too easy, not too hard. And the example that they gave us is we have a binary search tree that have 1, 2, 5, 3, 4, then 6. The question asks us to write a function. So this function that converts this binary search tree into a single linked list. So it's supposed to look like 1, 1, 2, 3, 4, 5, and 6. I guess they want us to create a sorted linked list. So as you can see, on the left side we have 1, 2, 3, 4, 5, 6, and the output is just 1, 2, 3, 4, 5, 6. What I'm thinking right now is so this is like black box function. If you look at this sequence, it seems like it is a in order. No, not in order. So you're supposed to go, you visit, go left, you visit, go left, you visit. So let's do visit left. I think this is a pre-order. So we visit, get 1, and then we go left, we visit, we get 2, and then we go left, and then we visit, gets 3. Then we try to go left, we can't. Then we try to go right, and we can't. And then we go up, and then we go right. Then we visit, we get 4, and then we try to visit left, visit right, but it doesn't have any childrens. So let's go up here and go visit right, and then visit 5, and go left, then I visit 6, and then it doesn't have any child, so just 6, and then so I think according to this, in order, no, this is a pre-order. So pre-order is basically mean you visit the node, you go left of the node, and then you go right of the node. I think pre-order will always give us a sorted result. Let's do another example. Let's do 6, 1, 4, 5, 2, 7. And that case, we have 6, and then we have 1. 1 go to the left because 1 is smaller than 6, and 4 is smaller than 6 but it's greater than 1, so 5 is less than 6, so it's however 5 is greater than 1, greater than 4, 5 is 2 is less than 6 but it's greater than 1 but less than 4, so 2. 7 is greater than 6. I don't think for this case pre-order will give us a sorted array or sorted linked list, so we would get 6. So if we do like pre-order, we would get 6. Get 6, get 1, get 4, get 2, get 5, get 7. So nope, pre-order doesn't guarantee that we will get a sorted array. Okay, what's next? Let's try to check what we're supposed to get if this is the case. Yeah, according to the hints on Leetcode, it say that if you notice carefully in the flattened tree, each node's right child point to the next node of pre-order traversal. So each node right child. So each node right child point to the next node of pre-order traversal. Point it to here, yeah. Yeah, I guess they do like pre-order, but I'm just not quite sure what the hint mean. If you notice carefully, in the flattened tree, each node right child points to the next node of the pre-order traversal. Oh, okay, that makes sense. So this right child, 2 is the right child of 1. So 1 is the parent of 2. So this is like right node, I believe. This is tricky. I have some idea of how to solve this problem, but it might not be the most efficient. But let's bear with me. Let's like walk through my thought process. So my thought process is to have a list that containing the pre-order. So I'm thinking of like having 1, 2, 3, 4, 5, 6. I'm thinking of like have a 6 variable, like 6 pointer pointing to 1, pointing to 2, pointing to 3, pointing to 4, pointing to 5, pointing to 6. And once we get this list, you can just remove the pointer of the last pointer. So we go through 1, we set left pointer to none, and we set second pointer, we set right pointer to 2, and this is none, and this is go to 3. You get the idea. But the problem is it might take up a lot of spaces if we do that. So let's say that we go with that route, with that idea. How would I implement this in the code? Let's call define solution. Excuse me. I might need some more spaces. So I need a list, like to store like pre-order. So I call it pre-order. Set it to a list, and then I would call a helper function. So the helper function will take the head and then the list, and the helper function is going to like modify the pre-order list. So like in the case that we already got like this list, you want to go through like the pre-order list. So for node in pre-order, we'll do node okay, I think it's better if we use the index instead of this. And for I in range of 0 to laying off pre-order -2, because we're going to load one index in advance, and also like the size of the array should be like -1 because the index started at 0. So we want to -1, and we minus another 1 because we look 1 index in advance. So first we want to do pre-order I dot left is equal to none, and then pre-order I dot right, assuming that our node containing left and right pointer, this is a value. So this would be pre-order I plus 1. So in the case that we have just like 1 and 2, what I'm doing right here is set this to none and set the right to 2. But But in the case that I have only like 2 nodes, like I want to check if pre-order if length pre-order is greater than 2, greater or equal to 2. What I want to do is because I want to set the right of this one to none, and also like the left of this one to none. So I would have to do pre-order and then length pre-order -1. Let's call it temp, and then temp dot right is equal to none. Temp dot left is equal to none. So what I wrote right here, it's basically what I drew right here. So just set the last node to left child and right child to none, because as you can see here, both child of number 6 is both of them are none. Because like this loop, if this was the example, our sign would be 2, right? 2 minus 2 would be 0. So it would only run once. Alright, so now let's look at helper function. So I think helper function is basically just a pre-order. It's basically just a algorithm for pre-order. So if root is not is you want to do pre-order dot append the root. So this is basically mean the same as like visit, and if root dot left is not none, we want to do pre-order. No, we want to call helper function. So in the case that the left child is not none, we want to go to the left. And then pre-order if root dot right is not none, call helper root dot right, and then here you will pass pre-order. There we go. So in the case, if this is the case, it would go visit 1, try go left, visit 2, try go left. So it would store 1, 2, 3, 4, 5, 6 in the list, and this order will set everything to none. I think this looks alright. Let me go ahead and type this solution into the IDE and see how I do comparing to the test cases. Alright, thank you for watching. Hope to see you guys soon. Bye.